So, hi everyone. We're super excited to be here today. So, first of all, I would like to thank the Things Industries for organizing every year such a great LoRaWAN show. And I thank you all as well in the audience for attending this brief ST conference. So today we'll deal with our latest series, STM32WL. We actually chose the name which is easy to remember. A W standing for wireless and an L standing for long range. So up to recent years, we've been hitting the market with our general purpose microcontrollers portfolio, historically constituted of three main segments: ultra-low power MCUs, mainstream, and high performance ones, depending on their internal architecture. And 2 years ago, we introduced our first wireless microcontroller with the STM32WB, with a B for Bluetooth. We really like easy names. And now we introduce our STM32WL. So what is that all about? Basically, we've been integrating on the same silicon die both an STM32L4 architectural basis and a LoRa-enabled IP on the same silicon die, right? And I really want to highlight this point because up to now, all the implementation on the market have been done in a discrete way, which meant either one package for the MCU and another package for the LoRa transceiver inside the same PCB, or one package for the MCU and another package for the transceiver inside the same module, or even sometimes one silicon die for the MCU and another silicon die for the LoRa transceiver in the same package, which is called in that case a system in package. Here, this is a totally new approach, and we are very happy to bring this first integration on the market and this additional LoRaWAN enabler, everything on the same silicon die. So actually, what does such deep integration mean? Of course, you will naturally understand that it will reduce costs of your bill of materials, but that's not all. Basically, inside the device, you have 4 modulation. Of course, you will be able to implement LoRaWAN through LoRa modulation, but that's not all, okay? Through GFSK, GMSK, and BPSK, you will also be compatible with Sigfox, and that's the first strong point to highlight, because that means that you guys, device makers, will need to have only one platform to rule them all, I would say. So if you have already a LoRaWAN compatible platform, then this will be compatible as well with the Sigfox. And by the way, to potentially other protocols, such as other proprietary protocols or other standardized protocols. Actually, we're already working with third parties to ensure that other well-known standardized protocols will be compatible with STM32WL as well. So if we have a look now on the block diagram of the product, of course, I won't detail all the blocks here, but rather focus on some of the most important ones. And as we were talking about the radio, I've already mentioned the 4 modulations that are available inside the product. And also, we are actually worldwide compatible through a linear frequency range from 150 megahertz up to 960 megahertz, okay? Another feature which makes this product compatible with worldwide implementation is the availability, internal availability of a dual power output, meaning one power output which can go up to 15 dBm, and another one which can go up to 22 dBm, okay? So that means that if you're a device maker targeting a European market, in that case, you would rather use the 15 dBm power output, because actually this one is more power optimized. Or if you target the American market or the Chinese market, in that case, you would need respectively 22 dBm or 17 dBm, yes, for Chinese market. And in that case, you would use the 22 dBm one, okay? Now, in terms of digital core, due to the fact that this device is actually based on STM32L4 architecture, the internal digital core is an ARM Cortex-M4 with its own memory protection unit, okay? And in terms of power management, actually, there are both an embedded LDO and an embedded DC-DC for more power efficiency inside the product, okay? Another very cool feature to highlight is your future ability to synchronize both the MCU part of the device and the radio part of the device with a single 32 MHz crystal. As mentioned previously, considering the fact that all the implementation of the market before have been done in a discrete way, you each time needed a megahertz crystal for the MCU and another megahertz crystal for the radio transceiver. This is not the case anymore with such product, so you will actually save one 32 megahertz crystal and thus reduce your bill of material again. Then, in the same way as what we do for general purpose microcontrollers, we have security features, so AES 256-bit for encryption, for example, but also true random number generator or firmware protection capabilities, with what is expressed here as PCROP, standing for Program Code Readout Protection. Last but not least, we hit the market with a BGS73 package. That means that you will have the flexibility to enable up to 43 GPIOs, okay? So enabling much more applicative flexibility. So it's totally legit to mention that our designers and engineers have been working hard to innovate inside such products. And actually, all the pink frames that you can see here deal with one or several patents. So for example, the optimized RF power management means that the power management of the device is actually shared between the radio part of the device and the MCU part. That leads to better power efficiency, better low power mode, silicon size reduction, and thus overall cost reduction of your total system. Then smart clock control stands for more robustness in front of clock oscillator failures, for example. Then flexible clock control means that the device will be able to provide a stable and regulated supply to an external oscillator through a GPIO and not through a dedicated pad. So that brings, here again, applicative flexibility. I mentioned previously that there are both a DC-DC and an LDO embedded in the device. But basically, to wake up DC-DC takes time. So whenever you will wake up your device from whatever low power mode, such as sleep mode or stop mode, you don't want to wait for the DC-DC to be ready. So what will happen is the following. Let's assume you use an STM32WL. It's in stop mode or sleep mode. You wake it up, then it will use the internal LDO to perform whatever functional operation that you want. And whenever the DC-DC will be ready, several microseconds later, then the device will automatically switch from LDO usage to DC-DC usage, bringing both functional efficiency and power efficiency at the same time. Then we have a flexible MCU supply, allowing power effective coexistence of parts with different minimum operating voltage, bringing more applicative flexibility in low voltage conditions. And then we have also smart stuff regarding the chip ability to recover from frequential drift, so more frequential accuracy and stability, okay? So as mentioned previously, we hit the market with a BGS73 package. The dimensions of such package are quite small because it's a 5 by 5 millimeter package, a tiny footprint for your future PCBs, right? And 3 different sizes of flash memory, in between 64K up to 256 KB, sorry. Okay, so and as mentioned previously, up to 43 GPIOs can be enabled as well. So we are confident in this chip's ability to tackle or address whatever vertical market, I mean LoRaWAN vertical markets, as defined by the LoRa Alliance. To name just a few, we have, for example, a 10 years lifetime commitment or worldwide compatibility for utilities. We have reduced BOM cost capabilities for smart cities, unique IDs and tiny footprint for logistics, good latency for industrial IoT, a really robust link budget for smart agriculture, or battery lifetime optimization for smart home, for example. So considering the fact that in LP1 use cases, the battery lifetime is of paramount importance, let's have a look on the power scheme of such device. So first of all, let's focus on the left column of such table. You will have a list, which is not exhaustive of the power modes of the device, so from shutdown up to run mode. The first thing to keep in mind is the fact that the set of peripherals and wake-up sources that will be available will depend on the power mode that you use. Meaning that, for example, from stop 1 up to run mode, you will have the full peripheral set which will be available. Whereas in stop 2 mode, which is more optimized in terms of static consumption, then you will have a subset of peripheral, but which remains rich enough to serve your applicative needs. Okay? Then, secondly, in all the power modes, except shutdown, you will have the ability to keep your RAM content. Okay? Very useful to keep your context, your applicative context. And last but not least, the radio part of the circuit, really important, will remain available in all the power modes except shutdown. So that means that basically, even if the MCU part of your device is on stop or asleep, the radio part of the device will still be able to send or receive data from the LoRaWAN network. Okay? So if we want to dig deeper now about these power modes, let's have and if you want to have a look at figures as well, let's have a top-down brief description about such power modes. So let's assume that you are using an STM32 WL in full run mode. Your the first choice that you will be able to make will be to use either an LDO, the embedded LDO, or the embedded DC-DC for maximum power efficiency. Another way to optimize your dynamic voltage consumption will be to choose in between two voltage ranges, because there are actually voltage scaling inside such device. Okay. Another way to optimize your dynamic voltage consumption is to stop your CPU clock. In that case, you will enter sleep mode. Okay. If you want to now optimize your static consumption, then you can enter stop 1 mode, for example. In stop 1 mode, basically, all the clocks related to the core supply will be stopped. Even better than that, you can power off some subparts of the core supply. You will enter step 2, 1 microamp as static consumption. To be even more aggressive in terms of power consumption, you can enter standby mode or shutdown mode. In standby mode and shutdown mode, the whole core supply will be powered off. The main difference in between both of them is the fact that in standby mode, you're still able to keep your RAM content. Okay? So the things to remember, basically, the peripheral sets and the wake-up sources set that you can use will depend on the power mode that you will use, and the radio will always be available whatever power mode that you use, except shutdown. Okay? And the last mode that we can also highlight here is what is expressed here as VBAT, standing for what we call the backup domain, which is the ability to supply only a very small part of the circuit with a small battery. In such small parts, you will keep only the RTC and the anti-tamper feature, and 20 registers of 32 bytes each. And in that case, you will be able to have some super interesting battery lifetime optimization capabilities. Okay? So if we have an even deeper look at the differences between the stop modes, let's have a look now at this table, and I want you to focus first on these two lines. So you can notice that in stop 2 mode, we have a 2.2 microsecond wake-up time, which is a very strong performances, but the consumption is 400 microamp. A very good trade-off to improve this is to enter stop 1 mode. In stop 1 mode, you will be able to divide your static power consumption by a factor 100, while still be able to achieve a 5 microsecond wake-up time. Okay? And an even better trade-off might be to use the stop 2 mode, 1 microamp as power consumption and 5.5 microsecond for the wake-up time. I remind that there is no influence from the DC-DC on the wake-up time, okay? With what I explained a few minutes ago. And you can notice on the last row of such table, the peripheral and wake-up sources set that remain available. So in step 0, step 1, you can do whatever you want with whatever peripherals, and in step 2, you still keep a rich peripheral and wake-up sources subset, because you still have low power UART, I2C, dual watchdog, a clock security system, etc. Okay? Now, in terms of RF performances, I want to really emphasize the fact that there were no compromises made during the integration of the LoRa-enabled IP inside such device on the RF performances, meaning that the RF performances that you can expect will be as good as what you will have in discrete solution, okay? In terms of TX, RX, or even sensitivity, no problem at all. Then I remind that we have worldwide compatibility through two main features, linear frequency range from 150 megahertz up to 960 megahertz, and a dual power output. Few words about the way to select your power output. Such selection is performed in a hardware way. You can notice at the bottom of such schematics the two power output, 15 dBm1 and 22 dBm1. So if you want to, let's assume that you want to select the 15 dBm1, okay? The way to do so is by using cells. So the bottom cells will select the 15 dBm power output, and the upper cells will be used to regulate your power amplifier through the internal DC-DC. In that case, you will be able to achieve up to 15 dBm in a programmable way, while being super efficient in terms of power consumption. If your goal is not to optimize power consumption, but rather your bill of material costs, then in that case, very simple, you just withdraw the upper self, and in that case, you will still be able to achieve 15 dBm, but your bill of material costs will be more optimized, okay? So now that we've described the silicon features about such product, let's have a look at some safety and security features and the ecosystem that comes with such device, okay? So in the same way as what we do for our general purpose microcontroller, we have safety features. To name just a few, we could think of ECC, CRC, backup byte registers, for example, or backup clock circuitry. All of these ensure that your device is working well whenever you are using it, okay? And in terms of security, the first security feature that I could highlight, for example, is anti-tamper detection. Indeed, considering the fact that in most of LP1 use cases, all your devices will be all around the world, you really want to protect them from any kind of attack. So, for example, with anti-tamper detection, if one device has been tweaked or open, you will be able to detect that, okay? Then we have, as mentioned previously, AES for encryption, or firmware protection capabilities through program code readout protection, okay? Now, I want to really highlight the fact that the chip is provided in an open way. There is no part number dedicated to LoRaWAN. That means that you guys, device makers, will always have the possibility to implement whatever you want inside such device. However, you're here because you love LoRaWAN, and we love LoRaWAN as well. And in such framework, we provide a LoRaWAN stack. It's provided in a source code format, okay? And by the way, it's production ready and has been certified for all the LoRaWAN regions in the world. So wherever you are, whatever market you target, you will be able to use this LoRaWAN stack. Few words again now about the main differences between the SoC approach and the discrete solution approach. So as mentioned, cost saving will come from the deep integration of such device. Also, you will be able to speed up a bit your time to market because your hardware design will be simpler, only one package, right? And in terms of software, everything is embedded on the same die as well. So in that case, also you can optimize your time to market, okay? Whereas usually for discrete solutions, the size of your PCB might be a bit bigger, and the communication in between the discrete parts might be a bit more exposed as well. In the same way as what we always do, we bring with such product an introductory ecosystem with it, okay? First of all, you will have nuclear boards for flexible prototyping, then some software tools along with it, such as Cube Programmer, for example, or a light version of CubeMX for pinout configuration or clock tree synthesis, for example. And then, of course, as just mentioned, we provide a LoRaWAN stack. And also, we will provide in the coming month a Sigfox stack for the device. Now, to insist on the cost saving of such that are enabled by such device. Regarding the silicon cost, we've already covered that. Less external components around it, single 32 MHz crystal, for example, instead of 2. And yeah, deep integration, right? Regarding the ecosystem itself, the LoRaWAN stack is free of charge, and the tools that come with it are free of charge as well. Now, each time we hit the market with a new device, we have what we call a 10-year lifetime longevity commitment. Sorry. That means that whenever we release a part number on the market, we commit in being able to sell the same part number for at least 10 years. And actually, such commitment is renewed every year. So usually, such commitment lasts for much more than 10 years. Okay? And now, if you want to remember only one slide of this presentation, it will be the following one. So the key points to remember regarding this device are the following one. First of all, you have multi-modulation capability, which will enable you to implement whatever you want on top of your LoRaWAN stack. Okay? More applicative layer, more proprietary protocols, or even sometimes more other standardized protocols. Massive integration will come from the deep integration that has been performed for such system on chip, single silicon die. The chip is provided in an open way. That means that you will always have the possibility to implement whatever you want inside it. Being based on STM32 L4 means that it's an ultra-low power platform, L4 being a best-in-class ultra-low power general purpose MCU on the market. The WL is IoT ready, I would say. We have seen all the safety features and the security features. And right now we hit the market with the BGA73 package, but actually other packages will come down the road. Maybe we will have a few words about that on our booth later on. Okay? And last, as just mentioned, there's a 10 years longevity commitment from us. Okay, so as you already saw, most probably, we have a very friendly and welcoming booth over there. So we really expect to meet all of you there, shake your hand, discuss. We have a team of 10 people from ST ready to answer all your questions about this product and discuss whatever you want. In the meantime, I thank you very much for your attention.